Hey guys, so now let's look at multiplying and dividing rational expressions. So the first one asks to determine the domain of a rational expression. We exclude values that cause, well, that's the denominator, to equal 0. Okay, so for each of the following rational expressions, we're going to determine the domain. And to find the domain, we always take the denominator and set that not equal to 0. Okay, so we're going to take the denominator, set that not equal to 0, and then just solve. Okay, that's how we do it. So we're going to take the denominator, so x plus 2, set that not equal to 0, and solve. So we'll subtract 2 from both sides. So x cannot equal negative 2. So that's the answer for the first one. So our domain, I don't know how you guys prefer to write it. So the domain equals, let's do set notation, x such that x cannot equal 2. Okay. And then this one we have to factor it first. So we know that there's going to be 2a's, right? Because a squared, 2a's. Factors of 18, same sign, going to add to equal negative 6. So it's going to be a minus, negative 9, a minus 6, and a minus 3, right? So a cannot equal 3 or 6. So here, our domain, x such that x cannot equal 3, and x cannot equal 6. Okay. So now we're going to simplify rational expressions. So to simplify a rational expression, we use the reduction property. Remember to always factor first and then divide out the common factors. So let's factor first. Okay, so the numerator, if we factor it, we know it's going to be factors of 20 opposite signs that give us negative 8. Well, that's going to be negative 10 and positive 2, right? So we could just say x minus 10, x plus 2, right? That's our top one. Now our bottom one's a little more tricky, right, because it's got the coefficient in the front, so we're going to have to use the AC method. So let's just do that. We know in the AC method we're going to be the front one down and the last one down exactly like it is. The last one is going to be negative 2, always, nope, no equal to 0 here. So 2 times a negative 2, right, the AC method, we know we always put in an absolute value. So 2 times a negative 2 in our absolute value bars gives us a positive 4. Factors of 4 that give us 3 are going to be 1 and 4. The larger one, you know, it's going to be different signs, so the larger one gets the plus and the smaller one gets the negative. Doesn't matter what order you put them in, but they each need an x if they're going to combine to give us a 3x, right? So negative 1x plus 3x. Okay. There's 4 terms, so we automatically know to go by factor by grouping. Greatest common factor from the first group, well, we see that that's going to be an x. So this is going to leave us 2x minus 1, greatest common factor. And I wrote that something down wrong. That's supposed to be a 4. I knew I did. It was like not right. So this should be 4x. Sorry, so wrong. So the greatest common factor from here is going to be a positive 2. So this is going to be 2x minus 1. Okay. So now we can see our factors, right? Our factors are going to be x plus 2 and 2x minus 1. Alright, so then the factors here are going to be x plus 2 and 2x minus 1. Now we can cancel our x plus 2's. And that's going to leave our x minus 10 over 2x minus 1. I kind of didn't put anything where it was supposed to, but this would go in this box. I kind of never do that, do I? Sorry for that. Okay. So now we're going to multiply these and simplify the product. So completely factor each polynomial in the numerator and in the denominator. That's our first step. So to factor our first one, we can see that the greatest common factor between these two is going to be x. So we're going to have x times x minus 4. And then if we factor this numerator, that is going to give us x minus 3, x plus 2. Now let's factor the denominators. This is the difference of two squares, so we know that this is going to be x plus 2, x minus 2. And this one's factored as far as you can go, right? Oops, that's a 4, showing not a 2. Cool. Now, it says multiply using the multiplication property. But that's kind of different. Like, that's the hard way to go. Let's go ahead and do our cancellations, right? So we could cancel this out. And then we have a positive 2 here. We could cancel those. So now we have x over x minus 2 times x minus 3 over 1, right? Because there's nothing on the bottom, so we could just write that as 1. Now we can do the multiplication, right? So this is going to be x times x minus 3 over x minus 2. And that is the most simplified form, so if you want to just copy it down again and be done, you can. So x times x minus 3 over x minus 2. Now let's talk about dividing. This is all jumbled like it sometimes gets. I cannot explain why that happens, so I don't know, I'm just not going to, I guess. So this one says y does not equal 0, p does not equal 0, and q does not equal 0. Okay, it's because this is in the denominator, and these are denominators as well. Okay, so to divide two rational expressions, we rewrite the division problem as an equivalent multiplication problem, and then follow the steps for multiplying rational expressions. If x, y, p, and q are rational expressions, then y cannot equal 0, p cannot equal 0, and q cannot equal 0. Sorry, that was hard for me to say. I guess you noticed. Okay, so whenever you have a fraction divided by another fraction, always think the top one, I wanted that to be pink since that was blue over there. This top one we keep, okay? So you just keep him the same. I gotta make that smaller because I gotta do something different with the division bar. Now this division bar right here, we always change him. We change him from division, right? He goes from division to multiplication, so we change him. And then, this guy down here, we flip, right? We want his reciprocal, so we're going to flip him. So we're going to start out, it's going to be x over y, and this long bar means division, so it's going to be divided by p over q, but what we want it to end up being is x over y. We change the sign to multiplication, and then we flip this last one, and we want it to be q over p. Okay, so keep, change, flip. So whenever you see division like this, just always think that. Keep, change, flip. Alright? Okay, let's do number 6. Divide the following rational expression and then simplify the quotient. So remember, this is keep. This is change. And this one is flip. So we're going to have 27 xy squared over 60 x squared y to the 4th times 24 y to the 5th over 36x. Okay. Now I know it says multiply, but I prefer And I think it'd be wise if you guys did it the same way. If you start canceling what you can, right? So we have 27 and 36, and 9 will go into both of those. So 9 goes into 27 3 times, and 9 goes into 36 4 times, right? And then 12 goes into 24 2 times, and 12 goes into 65 times. Now let's look at our variables, right? So we have this x and this x will cancel, right? And this y to the fourth, and we can just take this down to a 1, so y to the first power. Okay. And then we can, I'm going to switch colors because we can go even further, right? This 2 will go into this 4, so this is going to become a 1, and this is going to become a 2. So now let's write down what we have. 3 times 1 is going to be 3, and then it's going to be y squared. It's 3 times 1. Okay, and then 5x squared, and that's going to be 1, and well, it's just going to be y actually. 1 times y is just y, and then over 2. Yeah. Now we can do our multiplication and be done. So 3y squared times y gives us 3y cubed, and then 5 times 2 is 10x squared. And there we're done. Okay. Let's look at this. So a rational function is a function of the form r of x equals p of x over q of x, where p and q are polynomial functions and q cannot be 0, right? We know that. The domain consists of all real numbers except for those for which q of x equals 0, right? We can't have 0 in the denominator. Find the domain for r of x that equals 4x divided by 2x squared minus 6x minus 80. So we have to find where this equals 0. Well, let's just factor it, right? So it's going to be the AC method because we have a coefficient in the front. Either that or you can do the quadratic, whichever your jam is. I prefer, I guess I prefer the AC method. So AC method, we're going to have 2 times the negative 80, which is 160, right? Well, factors of 160 that are getting opposite signs that subtract to give us 16, well, that would be 10 and 16, right? Because that's 180, or 160. Oh, goodness, we're getting 180. So we know we always bring the first one and the last one down. So we have 2x squared minus 80. We're going to combine these to give us 6. So plus 16x minus 10x, right? Plus 6, yeah, because this is the plus, yes. So now we're just going to jump to our grouping. Greatest common factor from here is going to be 2x. And then from here we can factor out a negative 10, x plus 8. So we have 2x minus 10, x plus 8. So x equals 5, x equals negative 8. Yep. So those will be your answers on that one. Oh, if we can't, right, yes, if we cannot equal, because it's a domain. So your domain would equal x such that x does not equal negative 8, and x does not equal 5. Okay. Alright, I do believe that's the end of my part, and the rest of it is for you guys, so have a great day.